Chapter 5, Section 4, Products and Quotients Involving Radicals. In this section, we're going to learn how to multiply and divide radicals, and then, of course, simplify them. So, to multiply radicals, you have 3 steps. Number 1, multiply the whole numbers. Number 2, multiply the radicands, and the indices must be the same. And then number 3, simplify. And so we've already been doing a little bit of this when we were simplifying in the previous sections and when we were adding and subtracting. But let's look at how we're actually going to multiply. Now I know this is multiplication because there's nothing in between those two parentheses. So this says 2 radical 3 times 3 radical 5. So you're going to multiply your whole numbers, 2 times 3, which is going to be 6. And then you're going to multiply the radicals. So the square root of 3 times the square root of 5 is the square root of 15. And then you're going to simplify if you can. So how would you simplify? And this is what we talked about in the earlier sections. You have to look to see if there's a perfect square that will go into 15. And there is not a perfect square, so this is simplified. So let's look at this one. Again, multiply the whole numbers. 3 times 5 is going to be 15. And then the square root of 8 times the square root of 2 is going to be the square root of 16. Well, you know that the square root of 16 is 4, and then 15 times 4 is going to be 60. So like I said, we have done a lot of this in the previous sections. Alright, looking here, you have 7 times 3, which is going to be 21. And the square root of 6 times the square root of 8 is the square root of 48. And then we have to think of a perfect square that'll go into 48, and there are a couple, but I want to use the biggest one. So I think 48 divided by 16, yeah, 16 is 3. So to simplify this, we're going to split this up into 16 times 3, just like we did in previous sections. And this says 21 times square root of 16 is 4 times the square root of 3, which you can't do without getting a decimal, and we don't want any decimals. And so then we'll finish the multiplication. 21 times 4, which is going to give us 84, square root of 3. Okay, so let's try the cubes. 2 times 5 is going to be 10. Cube root of 6 times cube root of 4 is going to be the cube root of 24. So this time, instead of thinking of a perfect square that will go into 24, we've got to think of a perfect cube. And the perfect cube that's going to go into 24 is going to be 8 times 3. So we'll have 10 times the cube root of 8 is 2, and times the cube root of 3. So 10 times 2 is going to be 20, cube root of 3. Alright, so what about the distributive property? I know that this is the distributive property again because there's nothing in between this radical and this group. Now, inside this group, we couldn't add these unless we had like radicals, and there's no way to get like radicals. So since we can't simplify our group, we've got to multiply this radical 3 times the whole entire group, and that is your distributive property that we learned how to do early on in the semester. So we're going to take the square root of 3 times the square root of 6 and get the square root of 18. And we're going to do square root of 3 times the square root of 12 and get the square root of 36. And then we're going to simplify each one of these. Think of a perfect square that will go into 18, and that's going to be 9 times 2. And then, of course, the square root of 36 is simply 6. Square root of 9 is going to be 3, square root of 2, plus 6. And I cannot put these together because they're not like radicals. Remember, you've got to have like radicals before you can add things together. So that 6 would have to have a square root of 2 before I could put those together. And since it doesn't, they're not like, and you can't put them together. Alright, so the distributive property here, we're going to have 2 square roots of 2 times 4 square roots of 3. And remember, you cannot mix whole numbers and radicals. So you're going to do whole number times whole number, which is going to be 2 times 4, which is 8. And then radical times radical. So square root of 2 times square root of 3 is going to be the square root of 6. And then we're going to do, again, it is the distributive property. So we went here, and now we're going to go here. So you're going to have 2 times negative 5, which is negative 10. And the square root of 2 times the square root of 6 is going to be the square root of 12. And then we need to simplify where we can. There's not a perfect square that will go into 6, so 8 square roots of 6 is simplified. But the 12, there is a 4 that has a perfect square, so it's not simplified. So you have 8 square root of 6 plus 10 times 2 square roots of 3. And so you'll have 8 square roots of 6 plus 20 square roots of 3. And again, these are not like radicals, so we cannot put them together. Either this would have to be the square root of 3, or this would have to be the square root of 6 in order to put them together. So that's going to be your answer. Okay, so what about with variables? Same thing, distributive property. So we're going to have the square root of 6x times the square root of 8x. Since both of these are radicals, I can multiply them together. So we're going to have the square root of 48x squared plus square root of 6 times 12, or square root of 6x times square root of 12xy is going to be the square root of 72x squared y. And then, of course, we need to simplify. So the biggest perfect square that will go into 48 is going to be 16. So that's going to break down into 16 times, what do we say, 3? Yeah. And then the x squared, we know how to do that, plus, and then the biggest perfect square that will go 72 divided by 36. And that's going to be 2. So 36 times 2 x squared y. Alright, so let's bring out our perfect squares. Square root of 16 is 4, and the square root of x squared is x. So that's going to come out from under the radical, and the 3 has to stay under. Square root of 36 is 6, square root of x squared is x, and the 2y have to stay under. So again, these are not like radicals, so I cannot put them together. So this would be my answer. So let's try the cubes. Distribute. So cube root of 2 times 5 cube roots of 4. So there is a 1 here. So 1 times 5 is 5. Cube root of 2 times cube root of 4 is going to be the cube root of 8. And 1 times 3 is 3. 1 times negative 3 is negative 3. And then cube roots of 2 times cube root of 16 is going to be the cube root of 32. So now what we need to do is we need to simplify where we can. This is going to turn into 5 times 2 because the cube root of 8 is just 2. This is going to turn into 8 times 4. So we're going to have 10 minus 3 times cube root of 8 is 2. Can't take the cube root of 4. So we'll have 10 minus 6 cube roots of 4. And that will be your answer. Okay, so what if we have a binomial, 2 terms, times another binomial, 2 terms? Well, to remember to multiply a binomial times a binomial, you're going to do the full method. Basically, it's the distributive property. So we're going to take the square root of 3 and we're going to multiply it here and here. So the square root of 3 times the square root of 2 is going to be the square root of 6. And the square root of 3 times the square root of 6 is going to be plus the square root of 18. Then we're going to take this square root of 5 and multiply it here and here. So the square root of 5 times square root of 2 is going to be the square root of 10. Square root of 5 times square root of 6 is going to be the square root of 30. And then we need to simplify where we can, and the only one of these 4 that will simplify is this 18. 18 will break down into 9 times 2. And none of the others have a perfect square factor, so they won't break down. So your final answer is going to be the square root of 6 plus 3 square root of 2 plus the square root of 10 plus the square root of 30. And none of those are like, so you can't put any of those together. So for this one, we have 2 square roots of 2 times 3 square roots of 2, which is going to be 6 square root of 4. And then we have 2 square roots of 2 times 5 square roots of 7, which is going to be 10 square root of 14. And then we have negative square root of 7 times 3 square root of 2, which is going to give us negative 3 square root of 14. And then we have negative square root of 7 times 5 square roots of 7, which is going to be negative 5 square root of 49. So this one's going to simplify here. We have 6 times 2. Plus 10 square root of 14 will not break down because 14 doesn't have a perfect square that'll go into it. neither will 3 square roots of 14, but we will be able to put those together, but I'm going to wait just a minute to do that. And then 5 times the square root of 49 is going to turn into 5 times 7. So we're going to have 12 plus, and if you want to go ahead and put the 10 square root of 14 and the 3 square root of 14 together, that's fine. So you'll have 7 square root of 14 minus 35. And then you have 12 and negative 35 that you can put together. So we'll have 7 square root of 14, and then 12 minus 35 is going to be negative 23. And that's all that you can simplify. That's all that you can put together. Okay, notice these two are binomial multiplication. It is the full method still. So if you see these two, you can do the whole entire full method. But if you remember our patterns from chapter 3, you'll notice that we have a sum and difference on both of these. These are exactly the same except for one's plus and one's minus. And these are called conjugates. When we talk about radicals that are sum and differences, they're called conjugates. And we're going to use these later on in the chapter. And we're certainly going to use it in chapter 6 as well. So just remember, the sum and difference of radicals is conjugate. So if you ever hear me say the conjugate, that is when you have the sum and difference of radicals. So I'm going to work this problem, and I'm going to show you the whole entire full method, but you'll see what's going to happen. Square root of 8 times square root of 8 is going to be the square root of 64. And then the square root of 8 times negative square root of 6 is going to be negative 48. And then square root of 6 times square root of 8 is going to be positive square root of 48. And the square root of 6 times negative square root of 6 is going to be negative square root of 36. So, square root of 64 is just 8. These two are going to cancel each other out. They're opposites. And then minus the square root of 36 is just 6, and you get a number. And this is how we're going to get rid of a sum or difference of radicals in the denominator later on. So just remember, conjugates will give you just a whole number, or in this case, it's going to give you a variable. So anytime you multiply conjugates, the middle two terms are going to go away, such as this. So we can take a shortcut and do square root of x times square root of x is going to be square root of x squared. And then the square root of y times negative square root of y is going to be negative square root y squared. And again, we learned that pattern in chapter 3. And then the square root of x squared is just x, and the square root of y squared is just y. And so this would be your answer because you can't put x and y together. They're not like terms. But the nice thing is that the radical completely goes away. And anytime you multiply conjugates together, that's what happens. The radicals go completely away. So let's work with that. To simplify rational functions with a sum or difference of radicals as a denominator, you're going to multiply the numerator and the denominator by the conjugate. Now let me help you understand the difference here. Earlier, we multiplied, or we had fractions where we had the square root of 3 over something like the square root of 5. This is where you just multiply the top and the bottom by something that's going to give you a perfect square, and then you're going to get the square root of 15 over the square root of 25, which is going to be the square root of 15 over 5, and the radical goes away. But the difference is, here you have a monomial, here you have a binomial, and even here you have a binomial. So when you have a binomial, addition and subtraction in the denominator with radicals, you have to use the conjugate that we were talking about earlier. So to simplify rational fractions with a sum or difference as a denominator, you're going to multiply the numerator and the denominator by the conjugate of the denominator, and then simplify. So a plus b and a minus b are conjugates of each other. So what I want to do is I need to get rid of this radical in the denominator. That's breaking one of those rules. You cannot have a radical in the denominator. But since it's a part of a group, instead of just multiplying the top and the bottom by the square root of 6, I've got to multiply by the conjugate, which is the square root of 6 plus 9. So now look at what we have. On top, we have the distributive property. So we have the square root of 3 times the square root of 6, which is going to be the square root of 18. And the square root of 3 times 9 is going to be 9 square roots of 3. Remember, you can't multiply whole numbers with radicals. And then on the bottom, we have technically it's the full method, but since they're conjugates, it's a sum and difference. All we have to do is first times first and last times last. So the square root of 6 times the square root of 6 is going to be the square root of 36. And negative 9 times positive 9 is going to be negative 81. Okay, we can simplify the square root of 18. The square root of 18 is going to go into 9 times 2. We cannot simplify 9 square root of 3. And then the square root of 36 is 6 minus 81. So you see the radical goes away. We still have some cleaning up to do though. So the square root of 9 times 2 will break down into the square root of 9 is going to be 3 square root of 2. This is going to be 9 square root of 3. And then 6 minus 81 is going to be negative 75. Now we have one last step, and again, we learned this in chapter 4, I think. Remember that if you have something divided by a monomial, the only way that you can reduce the whole numbers is if the same number will go into every single term. And a 3 will go into all 3 of these. So we're going to reduce this by 3. So 3 will go into itself 1 time, 3 will go into 9 3 times, and 3 will go into negative 75 negative 25 times. So your final answer is going to be the square root of 2 plus 3 square roots of 3 over negative 25. Alright, so let's try again on this problem. So the conjugate of the denominator, I have an addition sign here with radicals, but I've got to get these radicals out of the denominator. So this is a group. And what I need to do is I need to multiply by the top and the bottom by the conjugate of this group. So what I'm going to do is I'm going to multiply the top and the bottom by 3 square roots of 5 minus 2 square root of 3. Top and bottom. So the only thing I did was change that middle sign. Change the middle sign. So again, on the top, that's going to be the distributive property. So 7 times 3 square roots of 5 is going to be 21 square roots of 5 minus 7 times 2 square roots of 3 is going to be 14 square roots of 3 over, and again when you multiply conjugates you just multiply the first times first and last times last. So 3 square root of 5 times 3 square root of 5 is going to be 9 square roots of 25, and then 2 square root of 3 times 2 square root of 3 is going to be 4 square roots of 9. So we'll simplify. On the top there's nothing that we can do because there's not a perfect square that'll go into 5 and 3, and you can't put those together, they're not like terms. But on bottom this is going to turn into 9 times 5 minus 4 times 3. So again, top's going to stay the same. 9 times 5 is 45 minus 12. And then 45 minus 12 is going to be 33. And all of these will not reduce by the same number. 21 and 33 would reduce by 3, but 14 won't reduce by 3. So this is going to be your answer. And remember, you can't reduce the 3 and the 33 because one's a radical, one's not. So just leave it be. Alright, let's try 2 more. For this one, I'm going to multiply by the conjugate because I have a group in the denominator that has a radical. So I need to multiply by the conjugate, which is going to be the square root of x plus 3. So on the top, that's going to be the whole entire full method because you have a binomial times a binomial. So the square root of x times square root of x is the square root of x squared. The square root of x times 3 is going to be 3 square roots of x. 2 times the square root of x is going to be 2 square roots of x. And 2 times 3 is going to be 6. And on the bottom, you can do the full method if you want to, but you're multiplying conjugates, so really all we have to do is the first times first minus last times last. Alright, so continue to simplify. The square root of x squared on the top, square root of x squared right here is just x. And then these two terms in the middle, 3x and 2x, or 3 square roots of x and 2 square roots of x, I can put those together and get 5 square roots of x, and then plus 6. And then on the bottom, again, the square root of x squared is just x minus 9. And there's absolutely nothing I can do with that. Okay, over here. Again, you have a group, not a monomial, but a binomial in the denominator that has radicals. That's how you know that you're going to multiply by the conjugate. So you're going to have the square root of x minus the square root of y, top and bottom. So on top, again, you have to do the whole entire full method. So we're going to do square root of x times 2 square roots of x, which is going to be 2 square roots of x squared. And the square root of x times negative 3y, square root of y is going to be negative 3 square root of xy, radical times radical. And then we're going to do negative square root of y times 2 square root of xy, which is going to be negative 2 square root xy. And then negative y times negative 3 square root of negative square root of y times negative 3 square root of y is going to be positive 3 square root of y squared. So again, on top, that's going to be the whole entire full method. Now, on bottom, we're doing conjugates, so first times first, which is going to be the square root of x squared, and then last times last, which is going to be negative square root of y squared. Alright, so let's go back to the top. Square root of x squared is going to be x, so we're going to get 2x there. And then those middle two terms we can put together. Negative 3 square root of xy minus 2 square root of xy is going to be negative 5 square root of xy. And then the last one is going to be 3y. Square root of y squared is y. On the bottom, square root of x squared is going to be x minus square root of y squared is going to be y. And there's nothing else that you can do. So I want you to try these problems on page 269. If you have any questions, bring them into class.